Okay, let's start. There's several types of sequences, and we've got. So I'll start by distinguishing them. We've got an arithmetic sequence, a geometric sequence, an oscillating sequence, and a periodic sequence. So let's make that nice and big, and I'll give you a couple of examples from each one. Now, an arithmetic sequence is a sequence where you have a constant term being applied. So I just go to insert. Okay. Alright, so say we've got something like 3, 5, 7, 9. What's a constant? What are we applying? What's the difference between them? 2. So we just add 2, add 2, add 2, and so forth. So therefore that's an arithmetic sequence. Okay. And then we just create some space. A geometric sequence is something like 2, 4, 8, 16, 32, 64. What's going on here? We're just multiplying by 2. Okay, times 2, times 2, times 2, times 2. This number here is actually called the common difference. We'll do this in more depth in the next couple of lessons. So it's D. It has a letter for it called D. And this one here is called the common ratio, and it has a letter R. And you could take any term and divide it by the term before it to get the common ratio. So you could do 64 divided by 32, gives you R. You could do 16 over 8, gives you R, etc. Okay? Now, an oscillating sequence is one where the sequence, let me write out the sequence, is where it behaves and does something like this. So you've got 5, 6, 5, 4, 5, 6, 5, 4. What's going on here? Sorry? It's repeated, but what else is going on? It's oscillating. What does that word oscillate mean? Physics? Do you remember your yes?
I don't know what it means in physics, but I know it means not English.
Okay, what does it mean in English?
It's like when you keep changing.
Keep changing, but it's more specific than that. An oscillation. Up and down, right? Yeah, it oscillates. Okay, it can be periodic. Generally it is. So, in this case, we have what we have is a middle number 5, okay, and it oscillates around that middle number. It goes up, it comes back down, it goes up, comes to the middle number, goes back down, goes to the middle number, goes up, goes to the middle number, and comes back down. So it oscillates around this number 5. Okay, then you've got a periodic sequence. Okay, so you might have something like 8, 0, 10. And then maybe we can do something like 10, and then do 12, and then you've got 8, 0, 10, 10, 12, etc. Okay, 1 minute. Here, the numbers repeat after a cycle, and the cycle doesn't necessarily have to have a pattern, but you can see 1, 2, 3, 4, 5. After every 5 numbers, the cycle repeats, and therefore this has a period of 5. Yeah, because after every 5 numbers, the whole pattern repeats. Yes.
No, it doesn't have to underscore.
Okay, is that okay? So that's what we mean by sequence. Now, a series, on the other hand,
So,
yes,
when you're oscillating,
yeah,
is it only oscillating when it has a repeating number, like the 5 and that one?
not necessarily.
Or
Oh,
does it go up and down,
it just go up and down. It can be it can converge, as you'll see when I do some questions. So it doesn't need to oscillate in a nice up down, way where it's the same amount that it goes up and down by. It can go up and down by various amounts. Okay, it will still be oscillating. Now this is, let's get definitions correct. These are sequences. In between them we have commas. Yeah, we've got commas in between them. A series.
Sorry, sir.
Yeah.
What do you mean by period 5?
Right. So what I said is, after every 5 numbers, 1, 2, 3, 4, 5, the sequence repeats itself. So therefore it has a period of 5. Yeah, it means it repeats after every 5 numbers. Yeah, that's what we mean.
Thank you.
Now, a series, on the other hand, is the sum of terms of a sequence. So, for example, if I took my arithmetic sequence there and I wrote 3 plus 5 plus 7 plus 9, this now gives me a series where I'm now adding this sequence. Now, the other thing to know is there is something called sigma notation, in which we write it like this. If you want to write down a series, we can write it as so. And over here is where you start your first term. This is where you end. And then this is your general term. So for example, if I've got something like this, AK, and I write down 1 and 5, okay, this means this equals A1 plus A2 plus A3 plus A4 plus A5. So I can use the sigma notation to work out or to express a series. We can define the sequence in 2 different ways. One of the ways we can define the sequence is through deduction. So let's just make that nice and bold. Okay. By deduction, we mean we have some general formula for the nth term. In other words, I can work out any term. I can work out the 100th term. If you tell me work out the 100th term, I can work it out. Okay? And an example is something like this. Let me just copy this down. And let's also put in this part here. Okay. So an example would be something like this. Okay. So here we've got a formula, and if I want to work out, for example, the 10th term, k will be 10. For the 10th term, k equals 10, and therefore A10 equals 10 squared take away 3, which is 100 take away 3, which gives us 97. And that's the 10th term. For example, according to this formula. Right? So using this general formula, you can work out any term. What I'd like you to do, I'll give you a couple of minutes. Can you work out the first 5 terms? Write down the 20th term, and then find the sum of the first 5 terms. Off you go. Right. First 5 terms. What do we have? First 5 terms.
Minus 2.
-2. 1. 6. Declan, what's the next one after 13? Layla, after 13? What do we get after 13? Excellent. No. What's the 20? Naima, what's the 20th term?
397.
Excellent. So 20 squared take away 3 gives us 397. What about the sum of the first 5 terms? What do you get? Yasmin? 4. Anjum? What did you get? The sum of the first 5 terms, part 3.
Oh, minus 2, 1, 6.
And what do you get when you add them up? Sorry?
Yeah.
40. Okay. Alright. So, well done. So those are sequences. So that's working with a sequence. Excuse me. Okay. So that's working with a sequence defined deductively, but we can also define a sequence inductively. Okay. And let me explain what that means first. Yes.
What would that sequence be?
What would what sequence be?
Would that be an arithmetic sequence or
Which one?
k squared minus 3?
The k squared minus 3. Does it have a common difference? No. So then it wouldn't be an arithmetic one. It would just be a sequence. It doesn't have to be an arithmetical or geometric. It doesn't have to be one of those per se. Okay? If it has a common difference, then it's arithmetic. If it has a common ratio, then it's geometric. But it doesn't have to be either one of those. It can be just a sequence. All right. One of the ways we can define a sequence is also in terms of the term before it. So, and that's what we mean by inductively. So this is defined by the term before. Okay, so here's an example where you've got ak plus 1 equals 2ak plus 1. And this is very important. You need to know your starting term. Without this, you wouldn't have sequence. You can start at different points. You can have a1 equals 10, and then that will generate a different sequence. You can have a1 equals million, different sequence, or minus 10, different sequence. So you need to know where your starting term is for an inductive sequence, and you need to know some sort of general formula. But when it's inductive, it tells it to you in terms of the term, before it. So if you say work out A20, A20 is 2A19 plus 1. Do we know what A19 is? No. So we can't just work it out just like that. Okay. We know it in terms of a relationship between the term before it. Okay. So what I'd like you to do is I'll give you a minute or two. Can you work out the first 6 terms of the sequence and then work out the sum of that sequence? Off you go. So, K, what does K actually mean? K just means, I'll write this down somewhere. K is just your term number. Okay? So, 1, they've told us is 0. Yeah? And if we were to substitute these values in, so when k equals 1, so here k equals 1, 1 plus 1 is 2, so you've got a2 equals 2 times a1, so over here you've got 2 times a1 plus 1. That means there's a relationship between a2 and a1. What's the relationship? It says take your a1, times it by 2, add 1. Do we know what a1 is? Yes, we do. It's the previous term. It's 0. So 2 times 0 is just 0, plus 1 gives us 1. What about a3 then? What does a3 equal? Well, a3, according to this formula, is 2 times the term before it, 2 times a2 plus 1. 2 times a2, what's a2? What does a2 equal? Good son. What does a2 equal to? 1. So you do 2 times 1 plus 1. 2 times 1 is 2, plus 1, that's 3. What about a4? Well, according to this formula, a4 means 2 times the term before it, which is a3. So 2 times a3 plus 1. What does a3 equal to? 3. Right, so 2 times 6 plus 1 gives us 13. Is that right?
3 times 3.
It's 2 times 3, sorry, yeah. There you go. 2 times 3, 6 plus the 1 gives us, so this should be 2 times 3, gives us 7, and so forth. Does that make sense now? Good son. Okay, thank you. Right, the second part, this is saying the sum of, okay, 6 AK. So this means A1 plus A2 plus A3 plus A4 plus A5 plus A6. That's what it means. Now, although this isn't generally written, the bottom part is k equals 1 and the top part is k equals 6. Now when you add them together, what do you get? 57. Okay? Is that okay? Yeah? Alright, what I'd like you to do is get on with the level 1 questions. Okay? Now normally I say pick level 1 or 2, or you could jump onto level 2, but in this case the level 1 are quite distinctly different to the level 2 questions. So I'll send out the answers in a minute, but I would like everyone to start on the level 1, question 1, and work your way down.